This is a quadratic in standard form. What we're going to talk about today is a quadratic in vertex form. And a quadratic in vertex form is going to be y equals a times the quantity of x minus h squared plus k. And this is vertex form. Now, who remembers from Algebra 1, if we were to graph a quadratic, what does it look like, or what is it? It's a parabola. So let's just go, I'm just going to show you right now. Let's just go to Desmos real quick. So we go to Desmos, we go to graphing calculator. And I'm just going to put in a quadratic. Y equals x squared minus, plus 5x plus 6. All right, do we agree this is a quadratic? Yes. Do we agree this is a parabola? Yes, this is a parabola opening up. Who remembers what makes a parabola open down? Anybody remember? No?
A negative number.
Good, a negative leading coefficient. So if the leading coefficient is positive, it's smiling, it's opening up. If the leading coefficient is negative, it's going to be frowning, it's opening downward. Now, there's one really important point on this parabola. The really important point is this point right here, because what's happening? This is more of our turning point. So from this point, we're moving the graph from left to right. It's going down, it's going down, it's going down, it's going down. It hits this point, and then what happens? It goes up, it goes up, it goes up, it goes up. Okay, so what do we call this point that turns the shift, that shifts it in from going down to up or up to down? This is called the vertex point. And when you're in vertex form, it actually identifies the vertex for you. So let's talk about some things. So when we have y is equal to a times the quantity of x minus h squared plus k, we're going to say that a tells us if it's going to open up or down. Oh, let's write this, sorry. If a is greater than 0, it's going to open up. And if it's opening up, meaning it's smiling, will there be a minimum point or a maximum point? Minimum, right? Because there's, go back to Desmos. Right, this was a positive A, and we had a lowest point. There is no highest point because it's smiling, right? It's going up forever. So there is one lowest point. There is no highest point. Let's see. All right, so we're going to open up, and that means we're going to have a minimum. If A is less than 0, which means it's a negative number, that means we're going to open down. And you think we'll have a max or a min? Maximum point. Okay, the combination of h comma k, that's going to be our vertex point. So hk will be the vertex. We're going to do a whole chapter just on parabola, so we will get into the nitty-gritty of everything parabola. But for the purpose of this chapter, for our lesson, all we need to know about A is that if it's positive, we're going to have a minimum, it's going to open up. If it's negative, we're going to have a maximum, it's going to open down. So we really only care at this point if A is positive or negative, really nothing beyond that. HK is the vertex point, which is really important because that is ideally the minimum or maximum point, right? Because that's when things start shifting. And so it tells us the highest or lowest point and also when things shift. Now, we know A, we know HK. What do XY represent? So A tells us if it's going to frown or smile. HK is the vertex. What does XY, X and Y represent? Stephen?
I have a question.
Okay.
So H would be the x coordinate and K is the y.
Yep. Enough.
tells us like where the parabola you're.
Yeah, it tells us all the points that exist on the parabola. You guys remember equation of a line, right? Y equals mx plus b. M is the slope. What's b? Y-intercept. What do x and y represent? All the points on the line. Same thing here. These represent, xy represents all the combination of points that exist on that parabola. Okay, so now what I want us to do is put in vertex form and identify, actually, no, I want to put in vertex form and state if it's a maximum or minimum. Okay, so here I'm going to start off with negative 16x squared plus 64x equals 0. Now to put this in vertex form, we're actually going to complete the square, but we're not going to do it the same way we would do it when we were solving for x. This time I don't want this equal to 0. I want this equal to y. So we want to complete the square, but I'm not doing it the same way I would complete the square if I were solving for x. So the first thing we want to do is leave everything, or bring everything to one side, not leave everything. So we're going to bring all terms to one side. That's assuming if it wasn't on one side. Are all the terms on one side here except for the y? So all terms in the same variable, I should say. All terms in same variable. So have I done that? Have I brought all the x's to one side? Yeah, we have that. Then what we want to do is pull out GCF of leading coefficient. Do not divide out on both sides. So that just means we're going to pull out that GCF and we're going to leave that GCF on that side. I'm not going to divide it out on both sides. So here, do we agree that the leading coefficient is negative 16? So I'm going to pull out a GCF of negative 16. And then I'm left with x squared minus 4x equals y. I'm not going to divide it. So last class when we were solving, wouldn't I then divide it on both sides? Yeah, I'm not going to do that. All right, now we're going to complete the square. So we go inside our parentheses. So we're going to complete the square for inside the parentheses. Half of 4 is what? 2. 2 squared is 4. So I have x squared minus 4x plus 4 equals y. So even though I wrote plus 4, in reality, I didn't add 4. In reality, I added a negative 16 times 4, which is a negative 64. Now I need to keep this balance. I can't just add 64 to one side of an equation and think it's keeping it equal. It's not. So in the past, wouldn't I just say, okay, well, if I added a negative 64 to the left side, wouldn't I just put a negative 64 on the right side and that would balance it out? Yeah, but I don't want anything on the other side, just the y, nothing else. So how would I balance out a negative 64 on the same side?
Add 64.
Add 64, you got it. So now what I'm going to do is I'm going to cancel that negative 64 by adding 64 outside the parentheses. And now we factor, so I have negative 16 times the quantity of x minus 2 squared plus 64 is equal to y. And now this absolutely fits the format that I want. A times x minus h squared plus k. So I put it in vertex form. Is this a maximum or minimum? This is absolutely a maximum because it's frowning, right? It's opening down. What is going to be the maximum point? Harv?
260.
You got it. The maximum point is going to be the vertex. And that vertex is 2 positive, comma, positive 64. How come it's not negative 2? Stephen? Good, because it says minus 8 in the vertex form. So this 64 is our max. So the whole vertex is the 2 comma 64, but isn't it the y coordinate that tells us how high or low we're going? So the 64 is our max. Yes.
If it was like x plus 2 with the vertex.
Yes. And we'll do one like that. All right, next one. Oh, actually, guys, let's go back to Desmos and just see. What did we say the vertex was? 264? Let's put in our quadratic and standard form. So y equals negative 16 x squared plus 64x. So we said it was a maximum, which is correct. This would be our vertex point, 2 comma 64. And that's what we got when we put it into vertex form. Pretty cool, isn't it? All right. Next one. So I have negative 2x squared plus 5x plus 20. Sorry, y equals this. Y equals this. So same directions. I want us to put it in vertex form and then identify if it's a max or a min. Also, let's identify the vertex. But before we do this, let's graph it and see what this looks like. So let's go to Desmos. I have negative 2x squared plus 5x plus 20. I forgot to put my y equals. There we go. So I zoomed back out. And do we agree this is definitely a maximum? And let's see what this point is. So it looks like it is the point negative 1.5, positive 1.25 comma 23.125. All right, let's see what we get when we put it in vertex form. So we said this is a maximum. What is the maximum? Looking for somebody. Ilya? You got it. Our maximum is the y coordinate. So we're 23.125. Let's go back and see now. Can I move that 20 to the other side? No, I can't move that 20 to the other side. I want to leave it. If I was solving like we were doing the other class, then could I move it to the other side? Yeah, then I would have to. But this time I'm not. I'm putting it in vertex form. So what we want to do is I want to leave it out and I want to group together just the x's. So now I'm going to have y equals, and I'm going to pull out that GCF of -2. I'm going to have x squared plus minus 5 halves x. Close that parenthesis, and I still have that plus 20 on the outside. Now I'm going to complete my square inside my parentheses. So I have to take half of 5 halves. Well, taking half is dividing by 2 or multiplying by a half. So this becomes 5/4, and then I'm going to square it. 5/4 squared becomes 25/4. Oh, 25/16. I lied. You caught me. 25/16. Am I really just adding 25/16 though? No, in reality, aren't I subtracting 50/16? So to cancel out subtracting a 50/16, what should I do? I should add a 15/16. 50/16 on the outside of the parentheses. Now I'm going to complete my square inside my parentheses. So we have y is equal to -2 times the quantity of x minus 5/4 squared. Can I simplify this 50/16? Are you guys okay with that? If I divide by 2, I'll get 25/8. And now to add the 20 plus the 25/8, I need a common denominator. So I'm just going to multiply top and bottom here by 8. So we're going to have 160/8 plus 25/8. Everybody okay with what I did there? Stephen? Why did I add 50/16? Oh, okay. So here, inside the parentheses, we added 25/16, right? But it wasn't really 25/16 because of the -2. So 2 times 25/16 is a -50/16. And so now to cancel that out and minus 50/16, I have to add 50/16. All right, so now we're going to have y is equal to -2 times the quantity of x minus 5/4 squared plus 185/8. All right, is this a max or a min? Max, because the a is negative. Is this a good vertex form for us? Yes, it absolutely is. What is the vertex? Stephen? All right. If you have a calculator or you go to the Desmos calculator, 5 divided by 4 is 1.25. 185 divided by 8 is 23.125. How much easier was Desmos, right? We just did all this work to figure this out, where Desmos gave it to us fairly quickly. All right, I want you guys to try this one on your own. Sorry. What calculator? For the word problems that we're going to do next class, I'm thinking of allowing you guys to use Desmos for it, which would make life a lot easier. But there will be other questions where you still need to know how to put it in vertex form. So you still need to know this.
Zero plus and this is.
Or like this.
The y coordinate of the vertex, that would be the maximum. All right, let's go through this. So the first thing we should have done is pulled out that GCF of -5. And now we're going to complete the square. Half of 8 is 4. 4 squared is 16. So I'm going to add 16 inside my parentheses. But in reality, I'm not really adding 16. I'm adding -5 times 16, which is a -80. So to balance this out, to balance out subtracting 80, what should I do? Add 80. So now we're going to have -5 times the quantity of x plus 4 squared plus 80. Is this a max or min? Max, because we're frowning, we're opening down. What is the vertex? Good. Why is it -4 and not +4? Stephen. You got it. So remember, it's x minus h. So the only way to make this a plus is if it was x minus a -4. No. So, oh, sorry. -5 times 16. Yeah, that's what we did, which is a -80. To cancel it out, we want to add the 80. And guys, if the vertex is -480, what is the max value here? 80 is our max. All right, we are actually stopping here for today. Next class, yeah, that's it.